In this session, we are going to learn about resistors. A resistor is a two-terminal passive element which implements the electrical resistance in the circuit. Okay, the resistance is a opposing the passage of electrical current or a flow of current through the conductor. The resistance behavior can be found out from the Ohm's law. We know that Ohm's law says that V equals to IR, where R equals to V by I. From this, we know that I is inversely proportional to the resistance. As the resistance increases, the flow of current in the circuit will be decreased. From the first circuit, here we will see that we have connected one resistor and a voltage source, and the current flowing through this circuit is 50 milliamps. That can be calculated from this Ohm's law, where I equals to V by R. Here the voltage is 5 volts and the resistance is 100 ohms. Then I equals to V by R. 5 by 100 equals to 50 milliamps. That is the current flowing through this circuit from the positive terminal of the voltage source towards the negative terminal of the voltage source. Okay. The resistors can be connected in different manners in a circuit, such as series and parallel, as shown here. In this circuit, the two resistors are connected in series, and in this circuit, the parallel resistors are connected in parallel with each other. Series connection is nothing but when the resistors are connected in a serially. That is nothing but the N terminal of first resistor is connected to the first terminal of next resistors and goes on, like this as shown here. The equivalent resistors of this series of resistors is nothing but the sum of all the resistance. The sum of all the resistance is the equivalent resistance of this circuit when they are connected in series. And what is the current and what is the voltage when they are connected in series? The current through each resistor is same when they are connected in series, as shown here. The current is 25 milliamps in the resistor 1 and 25 milliamps in the resistor 2 as they are connected in series. Whereas voltage is different for each resistor as proportional to the resistance. The voltage across each resistor is different with proportional to the resistance of that particular resistor. Now, when the resistors are connected parallelly like this as shown here or as shown here, the resistance, equivalent resistance of that particular circuit can be calculated with this formula. Okay. Then, and the current through the each resistor is different with proportional to the resistance, whereas voltage is same through each resistor. The voltage is same across each resistor. Now we will see with an example by calculating the voltage and current for these circuits. When the resistor R1 and R2 are connected in series, the equivalent resistance is sum of these two. That is 100 ohms plus 100 ohms equals to 200 ohms. Then the current flowing through the circuit is V equals to IR, I equals to V by R. That is 5 by 200 equals to 25 milliamps. We can see here the current flowing through this circuit is 25 milliamps, where the voltage across R1 and R2 is different. V1 is nothing but the voltage across R1 is V1 equals to I into R1. I is 25 milliamps and R1 is 100 ohms. Then when I and R multiplied, the voltage across the R1 is 2.5 volts, and we are using the same resistance here. Then the voltage across the R2 is also 2.5 volts. The total voltage in the circuit is V1 plus V2 equals to 5 volts. Now we will see how to calculate the current and voltage in a parallel circuit. When the resistors are connected in this fashion, then the circuit is said to be the resistors are connected in parallel. The resistors are connected in parallel. Okay, when the resistors are connected in parallel, the equivalent resistance can be calculated with this formula. The R1 is 100 ohms and R2 is also 100 ohms. Then the equivalent resistance in the circuit is 50 ohms. I said earlier the current through the each resistor is differs, whereas the voltage is same. So current through the resistor R1 is I1 equals to V by R1, 5 by 100 equals to 50 milliamps, and we are using the same resistor for R2, so we will get 50 milliamps through the R2 also. Then the total current in the circuit is 100 milliamps. That is nothing but I1 plus I2 equals to 100 milliamps. Whereas the voltage is same across each resistor.